A goal of research is that it should be able to solve real-world problems. So during senior high school, my team and I recognized the problem of heavy metal contamination. Water pollution is a serious environmental issue and a rising global concern that has mainly resulted from industrial activities. And heavy metals actually account for about 31% of all waste found in water. These contaminants deprive people of clean drinking water. They can damage ecosystems, threaten biodiversity, and they could also accumulate inside organisms, including the fish that we consume, or they could find their ways in waterways, becoming a risk factor for developing certain illnesses and diseases. Assessments actually done found that significant levels of heavy metals were present inside fish and macroinvertebrates that were sampled from Manila Bay. Many other locations in the Philippines alone exhibit water pollution and heavy metal contamination to a great extent. Under the supervision of the DLSU Chemistry Department, our SHS research group decided to investigate a material called a hydrogel that could potentially have the ability to retrieve heavy metals from contaminated water. We made use of chitosan obtained from chitin by deacetylation. Chitin is an abundant biopolymer that is non-toxic and readily available. Hydrogels are simply three-dimensional networks of hydrophilic polymer chains that have the ability to imbibe large amounts of fluids, manifolds its own weight while maintaining its structure. These properties make them ideal for potential water treatment applications. We cross-linked chitosan and introduced Kaolin clay, which is a naturally occurring clay that exhibits a layered structure. We synthesized different configurations of these chitosan-clay hydrogels based on percent by mass loading, 0%, which is pure chitosan hydrogel, 1, 3, 5, and 10% clay loading. We swelled the films in a 10 parts per million solution of lead for 24 hours, recorded their swelling behavior, and analyzed the immersing solution by AAS for the change in concentration of lead. For reference, just 0.015 parts per million is already toxic for human life, and our testing conditions were at 10 parts per million. We have successfully prepared stable, physically cross-linked chitosan-clay hydrogel films, and we discovered that they have up to twice the swelling capacity of unmodified chitosan, and that the introduction of Kaolin clay increased the lead uptake characteristic of the chitosan hydrogel, where lead uptake is also confirmed by the detection of lead through EDX measurement.